Section 2.5. Mechanical versus digital. Ciphers can also be classified according to the means used to produce them. The earliest ciphers were done entirely by hand, not using pencil and paper, but rather stylus and parchment, or stylus and clay tablet. The first mechanical means of encipherment was the skytale, or skytale, pronounced skytali, used by the ancient Greeks and Spartans, probably as early as 700 BCE. This consisted of a rod with a narrow strip of leather or parchment wound around it, so the edges of each turn carefully matched the edges of the adjacent turns. In other words, there were no gaps and no overlaps. The letters of the message were written across 2 or more turns of the strip. When the strip was unwound, only disconnected pieces of the letters were visible, so that an enemy would not recognize that it contained a message. Additional squiggles or patches of color could be added to make it look like a decoration. The sender kept the staff for reading and writing future messages. Messengers could wear the strip as a belt or use it to tie up their hair or cinch their saddles. The recipient needed a rod of identical diameter to reconstitute the message. Messengers, of course, were not told the purpose of the ribbon or thong. It might even be sewn into their garments without their knowledge. There is an image of a skytale in the 1593 edition of De Occultis Literarum Notis by Giovanni Battista Porta. It shows how each Greek letter spans several turns of the leather strip. Here is a modern version. The Greeks kept the secret of the skytale for about 700 years. The Romans, however, were not so successful. Eventually, their enemies in northern Europe learned the meaning and use of these rods. So the Romans invented a special measuring tool consisting of a hollow brass or bronze dodecahedron, a solid shape with 12 identical pentagonal faces, with a circular hole on each face. These holes allowed them to make wooden rods of precisely the correct diameter. When a governor, satrap, ambassador or spy was sent to a post that required travel through hostile territory, it was safer to carry this tool than to carry an actual skytale that could be captured. The 12 holes had different diameters to allow for secure communications with other governors, ambassadors and spies. For example, small for Londinium, now London, medium for Lugdunum, now Lyon, and large for Tarraco, now Tarragona in Catalonia. So far as is known, the purpose of these dodecahedrons was never discovered by the northern Europeans, or, for that matter, by modern archaeologists. Archaeologists have proposed a plethora of preposterous purposes for these artifacts, such as children's toys, saddle ornaments, practice pieces for blacksmiths, candle holders, range finders for artillery, or, the answer of last resort, religious objects. This is a bronze Roman dodecahedron found near Tongeren, the oldest town in Belgium, and displayed in the Gallo-Romines Museum. Here is an interesting side note. If you look up skytale in Wikipedia and other websites, it says that the skytale was used to produce a transposition cipher by writing each letter within 1 turn of the strip. This is wrong. Such a strip would easily be recognized as a cipher message. Whether or not the enemy could read the message, they would certainly not let the messenger deliver it. A thorough examination of the whole letter versus broken letter issue can be found at cryptiana.web.fc2.com/code/skytale.htm. In 1841, Edgar Allan Poe, who was a talented cryptographer, wrote an essay, A Few Words on Secret Writing, which gives a good description of the skytale and his method for decrypting these messages by matching up the broken fragments of letters. To compound this error, if you look up transposition cipher in Wikipedia, it says that the skytale was used to produce a rail fence cipher, also called a zigzag cipher. A rail fence cipher has columns that alternate up and down. Writing a message either along or around a rod does not involve any changes of direction, so if a Scytale were used to produce a transposition cipher, the result could be a columnar transposition, never a rail fence. I corrected these errors in Wikipedia, but my corrections were deleted. I have given up trying to be the Wikipedia police. A 1960s version of the Scytale was to sort a deck of computer punch cards, write the message in pencil on an outer surface of the deck, and then thoroughly shuffle the deck, leaving just scattered dots. When the deck was run through a card sorting machine, the cards would be restored to their original order, and the message could be read. This idea was widely discussed by programmers, but I do not know if it was ever put into practice. Another modern equivalent is to write the message on the blank back of a jigsaw puzzle and then scramble the pieces. The receiver needs to solve the puzzle and then flip it over to read the message. Another mechanical cipher was the Jefferson wheel cipher, invented by Thomas Jefferson sometime between 1790 and 1793. It consisted of 36 same-sized wooden discs threaded on an iron rod to form a wooden cylinder. Around the exposed edge of each disc, the 26 letters of the alphabet were written in some scrambled order. The discs could be rotated independently to spell any message. Versions of the Jefferson cipher using discs or paper strips were used as recently as the 1960s. Many types of disc ciphers were developed from the 15th through the 19th centuries. The most common type used several thin, flat concentric discs that could be rotated around a center pivot. Each disc had the alphabet or some set of numbers or symbols written in some order around the rim of its upper face. The discs got progressively smaller so that all of the alphabets could be seen at the same time. The discs were aligned in some position, and encipherment consisted of finding the plain text letter on one of the discs, then using the corresponding letter or symbol on one of the other discs as the ciphertext letter. Later types of disc ciphers advanced the inner disc after each letter was enciphered, either manually or through a clockwork mechanism. This is a picture of the Leon Battista Alberti cipher disc drawn by Augusto Buonafalce from his 1467 book De Compendis Cifri, image distributed by Wikimedia Commons. Starting in 1915, a long series of electromechanical rotor ciphers were invented. The most famous is the Enigma machine, developed in the 1920s by German engineer Arthur Scherbius. Dozens of types were marketed up through the start of the computer era. They all produced stream ciphers. The basic idea was that the substitute for a letter was determined by the path that the electric current took through the series of turning rotors. After each letter was enciphered, some of the rotors turned, controlled by various cams, gears, lugs and pawls, to change the substitutions in myriad ways. So if the word infantry came out as PMRNQGFW, that might not happen again for billions of turns. Since the 1960s, cryptography has become increasingly computerized and digital. The Data Encryption Standard, DES, was developed by IBM in 1975 and certified by the National Bureau of Standards in 1977. This touched off a series of block ciphers with names like Serpent and Twofish, culminating in the Advanced Encryption Standard, AES, adopted by the National Institute of Standards and Technology, NIST, in 2001. This class of ciphers is covered in Chapter 11. The progression has been from manual to mechanical to electromechanical to digital.